All right. Also, probably not as big as the track, but similar. You have sound, right? So I'm only going to put down 3 of them. Sound 2, sound 1. Okay. So you load those from the SD card. You put them into memory, or you know where they are in memory. Okay. Then there's 2 ways you can store these tracks. One, when I go tap, 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 I could just store, there was a tap, no tap, no tap, no tap, tap, no tap, no tap, no tap, tap. I could do that. Okay, so I'm not storing the actual audio. I'm storing that at this time I should play this sound. And at this time I should play this sound. And at this time I should play this sound. So that's one option. You don't even store the actual song, okay, in these. Does that make sense? Another option, okay, which is probably what you guys were thinking you wanted to do, could be when you tap your finger, you copy this whole thing into the track. Okay, you essentially, whatever this thing looks like, you put it there. Whatever this one looks like, you know, since it'll be tied to. So yeah, there's some overlap there on purpose, okay? And then there's this one. And then there's some overlap on this one because the person's tapping in that way. And then maybe there's also a sine wave on top of that. So there's all the waveforms smashed together, okay? And it stores them into the tracks, all right? So the output is the summation of all of these, which is really hard to draw. But what actually goes out to your speaker is it goes through and adds all the values at one spot and adds all the values to the next spot, which is, like, it's going to be really hard to draw again. But it adds them together. Okay, and you're only going to get one number in here. Then when you want to store it, you just copy this into whatever you want to copy it into. So if I want to put that output that's ongoing and I want to store it into this track, I can do that. Okay, so that didn't make a whole lot of sense. Let's try this again.
Yeah.
Let's see if we find a different way to do it. Hey, buddy, what's up?
Did you get the email that I sent you about the UAV?
Yes, I have not responded to it, obviously. I was out for a couple days.
Okay.
But it looked good. We do need to jump on that. Sorry about that. Yeah, I'll make sure it happens this morning. All right. Okay. So here's
I know what you mean by adding waves, but we're having trouble on how to program it or.
Okay. So yeah, so we can talk about that. I'm going to take a different approach. So these we don't do anything with. It's only the output. So when I'm tapping my fingers, it copies these sounds into this output buffer, which while I hit my fingers, one part of my program copies things in, and another part of my program, all it does is output the sounds in sequence. And it doesn't do anything but this. And it just walks through the array, okay, outputting sound. Which means that I tap my fingers and the sound gets copied in here right when I do it, and then this other piece of my program takes care of outputting sound. All right? Does that make sense?
Okay.
Then once it's all done, I have the option to save this up to a track. This whole output buffer. Okay? All right, so how do I go about doing this? I'm going to have to erase a little bit of this. So how are you planning to make your wave output right now anyways? You can use a timer.
Yeah.
Use a PWM.
Yeah.
Okay.
The output port.
Okay. So what you need is you need a timer vector or timer interrupt, probably the overflow. So the timer interrupt overflow. What happens in here is it looks at next number, changes output. So this is this thing, where every so often you have to set the time, it doesn't interrupt, and looks, what's the number now, and changes its output. And then it changes the output to the hardware, and the hardware actually makes things go back and forth. Okay, it's not your software turning a pin off and on. You set up the timer properly. You're probably going to want to do a PWM output so that the hardware takes care of that. Then, so this is one function, one interrupt. In your main program, so not your interrupt, in your main program, you're going to be looking at your buttons, right? And it's going to say if, let's see, finger 1 pressed, you're going to copy sound 1 into output. And then it's just going to go ahead and, okay, I'm going to copy it in. 1, 2. And it does this really fast. There's no delay. It's as fast as it can possibly do it. It copies this in. Right? Because this thing is going a little slower, and it's just taking care of making the sound. This thing, at a megahertz, as fast as it can, copies the data in so that it's ready. So now here's the question. What if all of this gets copied in, and then I want to copy this in, but I'm overlapping a little bit? What happens to the overlap? What happens in here?
They add together or?
Right. Don't just erase it. You want to add it together. And it's not just adding.
Can we just erase the first one?
Well, you
Well,
wouldn't
which
want to
one
erase it because that
is
sound
it?
wouldn't finish. And if it's just adding, the problem with adding is if you have 5 sounds, that means by the time you get to the end, your sound is going to be really huge. And it might be too big of a number to fit in memory. So you might not want to add the whole thing. You might want to only add a part that's been divided down a little bit smaller.
Write it down.
Or averaged. You might want to average that point.
Okay.
So now thinking about the memory, let's assume these are 1 byte each. So you can go 0 to 255. That's the biggest number you can put in each spot. So if this WAV file in here, let's say the end of this has the number 150, and this one here has the number 150, and you add 150 and 150 together, what do you get? 300. 300 is too big.
Yep.
But what if I always add in half?
So when overlapping, just divide it by 2.
Okay, but what if I also put in a third one?
So just all divided by 3.
All by 3.
But we'll have 5 sounds, right? So just divide it by 5.
Mm-hmm. So you have 2 ways you can do that. One, you can do it in your program, or when you make these files to start out, when you load them on, make sure that there's nothing in this file greater than 50. That's your biggest number. Because you have 5 audios. If the biggest number in any of these 5 sounds is only 50, it'll never be too big.
Right.
The truly the best way to do it, but takes a little more math, is to use the original number, put it in, and then when you put the next one in, you average. Okay, and then when you put the next one in, you average. But the problem with doing that is you have to know how many waves are already in there, because you remember when you do an average, you add them up and divide by. If there was 2, you'd divide by 2. If there was 3, you'd divide by 3. If there was 4, you divide by 4. So then somehow you have to remember how many things, how many sounds are there. And that's hard. So this works really well. And I think it would be more than enough. It's going to be very quiet unless you're hitting multiple buttons. That's the problem with it. But
how to get these things in real coding and design.
to start. So you should look into how to implement this, and then if you have real code, I can help you with it. But we have to bring the code in so we can look at it together. Code and hardware together.
Okay. Right, so video done.
Hmm?
The video's done, right?
Yeah, we're good. And it's did you guys do